Welcome to integration 5. We're going to start off by integrating cos squared x with respect to x. Don't bother looking for this one in your standard results. You need to use a double angle formula, in particular this one. So cos of 2a is equal to 2 cos squared a minus 1. And this lets us turn something we can't integrate into something we can. So if we just rearrange this, we get cos squared a is equal to cos of 2a plus 1 divided by 2. And that's what we're going to substitute here. So we've got cos of 2a, or rather x, plus 1 divided by 2, and that's with respect to x. And now we're going to take the half outside the brackets, so outside the integral sign, and that leaves us with cos of 2x plus 1 with respect to x, and that's now quite a trivial integration. So it's a half. Cos 2x goes to a half of sine 2x, and then 1 obviously goes to x plus c, and finally multiply it out to give us a quarter of sine 2x plus x over 2 plus c. If you couldn't do any of these on your own, but you understand it after watching the video, then why not go back and have another go and see if you can do it without looking at the video, because that's still quite a substantial challenge. Okay, so we've got an integration here by substitution. We're given the substitution, so let's start off by finding out what to substitute for dx. So I'm going to differentiate this implicitly. So we've got 2u du by dx equals, and then we've got 2x there. And we divide both sides by 2, and that leaves us with u du divided by x equals dx. There's our substitution for dx. So let's go ahead and make that substitution. So we've got the square root of u squared on the top, because that's u squared, and underneath we've got our x still, and then we've got this substitution here, so we've got u du over x, and that gives us a u squared on the top, so we've got the integral of u squared over x squared with respect to u. And you'll notice I didn't substitute for the x's here. That's the reason. It's always worth just waiting before you do your second substitution. Of course, x squared, we can get x squared out of this thing by rearranging it. So we've got x squared is equal to u squared minus 4. So this integral turns into u squared over u squared minus 4 with respect to u. And whatever you do, don't cancel those two there. You'll be tempted to, but you'll be committing that classic sin because you won't be cancelling common factors, of course. Now, what we've got here is a top-heavy algebraic fraction. So let's start off by doing the long division. So we're going to divide u squared by u squared minus 4. And that's obviously plus 0u plus 0, just to keep the form there. U squared into u squared goes once, multiplied by that, so we get a u squared and a minus 4. And then you subtract, that goes to 0, and we end up with positive 4, because 0 minus minus 4 is 4. So that means that this algebraic fraction is 1, which is that bit, plus the remainder, 4, over the divisor, which is u squared minus 4. Now, the next thing to do, we've done the top heavy part, so now we're going to split this into partial fractions. So we have 4 over, and it's the difference of 2 squares on the bottom. Hope you spotted that one. So we've got plus 4 plus 2 even, and u minus 2. So let's have a over u plus 2 plus b over u minus 2, which gives us 4 equals a times u minus 2 plus b times u plus 2. And if u equals 2, then that disappears, leaving us with 4 equals 4b, so b equals 1. And then if we put minus 2, we get 4 equals minus 4a, therefore a equals negative 1. So over here, back at the ranch, we've got 1, and then a is minus 1, so it's minus 1 over u plus 2, plus 1 over u minus 2 with respect to u. Okay, a bit more room there, and now we can actually integrate. So the 1 goes to x, sorry, it goes to u even, and then we've got minus ln of u plus 2 and then we've got plus ln of u minus 2 plus c, of course. And finish off, we can write that as a single natural logarithm. We've got u minus 2 over u plus 2. I'm pretty sure I've messed up a sign there somewhere. No, maybe that's okay, we'll see. Plus c, and that gives us, if we substitute back for x now, x squared plus 4 plus ln, this is not a pleasant one, of root x squared plus 4 minus 2 over root x squared plus 4 minus 2 plus 2 there, plus c. Okay, I'm just going to have a little look for my signs. And now on to number 3. Okay, so we've got integration by parts here. So as usual, unless you've got an ln floating around, then x is u, which gives us a u dv by dx equals 1. dv by dx is equal to our sec squared x, which means that v equals tan x. And now we can just substitute. So uv, so that is x tan x minus the integral of v, which is tan x du, which of course is 1. And then we've got x tan x, and if you integrate tan x, you get ln of sec x. Another one to make sure you know there. And that's it, job done. And finally, our last little effort for tonight, or today, or whenever it is you're listening to us. This is actually a lot easier than it looks. So, first of all, the integral of 1 over 2x is a half ln of x. And then what we've got here is another standard, very standard result. It's 2 times minus cot x plus c, which of course simplifies to a half of ln of x minus 2 cot x plus c. And there we go.